Hey everybody, welcome to my Roblox Luau learning course. In today's episode, we're going to be going over tables, looping, as well as the Roblox data model. Let's get started. So why do we use tables? Well, tables are used to conveniently group data into one section. For example, we could have a function that returns a list of everybody's coin balances. This could be done with tables. Tables can return either a list or they can return a key value map of data. They're also widely used for different types of behavior, including classes, which will be discussed in a later episode. Just like any other data type, tables can be defined in a variable. Create a variable here. We can define a table by using the curly braces, or curly brackets, however you want to call them. You see, this is how you define a table. This table's empty, and we can go ahead and add data to it. They can be separated with commas. They can also be separated with semicolons. There's two different data types within Luau. We have the array table, which is just a list of data with no key indexes. If we go to the dictionary table, you can see that there is a key provided with a value. Very similar to defining a variable. You can either define them within this quotation mark brackets, or you can just write it directly, as long as it doesn't have a space in it. If it has a space, it won't work, and that's what this would be used for adding that space. So now that we have a general idea of how tables are written, I've created two little example tables to kind of show a real scenario where you'd use them. So I have this variable called player data here, and it is assigned to a table. The table has a coins index, it's assigned to 250. It has a gems index, it's assigned to 5. It also has a subtable assigned to it called unlocked ducks. So it's a table inside of a table, and this table is an array table that contains a list of all of the unlocked ducks that the player has. We also have this dictionary table right here called duck colors, and it has a list of different colors that the ducks have. So Luau has this class called color3, and it has a function called from RGB, which takes in 3 0 to 255 numbers to define the color. The red color, the green color, and the blue color. If you click on these, you can see all the different colors that it currently has. So for example, the lava duck has this orangish red to signify lava. The epic duck has a yellow duck color. The dirt duck has a brown dirt color, and the grass duck has a green grass color. So you could use these duck colors to color the duck in the game, or maybe you have a user interface that has a list of all the ducks, and you want to color the text that says the duck name to be the same color. You could use these to grab the color that you want to set the text to. So we have these tables, but how do we get the data within them? Well, for array tables, they have this thing called indexes. They're this magic imaginary index that you don't actually see, and it starts at 1. So for example, this 100 number has an index of 1 because it's the first element within the table. Moving on to +1, that'd be 2, which is this 200 value. +1, 3, be this 300 value. So in order to actually index it, you can create a variable, and then you type the name of the table you want to index, which would be array example for me here. And then you create some brackets. Inside the brackets, you can type the index. So if we wanted to get 200, we would say, oh, this is the second element, so we type 2. So now A would equal 200. A similar thing applies to dictionary tables. If we create another variable here and try to index it, instead of typing a number, we would type the key that we assigned to it. So these keys are actually strings. In order to do that, we would just grab the string name. If I want 200 here, I take the 200 key. I put my brackets down, add quotation marks to signify that it's a string, and then paste my key in there. So now B, it'd be this table's 200 value. So 200 is the key, and then this is the value, which is 200. So now B would equal 200. You can also index these dictionary tables by using a period instead of wrapping it inside of brackets and quotation marks. So if we put a period, you can see it actually autofills all the different options for this table here. If I could just click on 200, you can see .200. Now we're indexing 200 value. There's also a few different methods we can use for tables using the global variable called table. There's a few different ones here, but I'm only going to go over a couple of them. First and foremost is table.insert. We want to add a value to an array. We can use table.insert. Its first parameter here is t, which is just a table here. So if we wanted to insert, say, 400 to array example, we would say that we want to insert into array example, then we comma. It takes a value now. Like I said, 400. We can put it in 400, and now array example will turn into this. When you click on the function here, you can actually see that it says 1 out of 2. If you click this arrow, you can see that there's another possible parameter that we can put into our argument here. It says position. So what position does is it inserts at the position that you want. So let's say we wanted to insert right before 100. We wanted to put, like, I don't know, the number 50. So we want to put it at 1, first index. So instead of having 50 here, you can see that it wants a table, then the position, and then the value. So instead of putting the table and the value, we would put table, position, value. So now this array would change to be this instead after we ran table.insert. Let's say we wanted to remove a specific value from an array. Let's say I wanted to remove 200 from this table array here. Well, there is the table.remove function. It takes in a table and then the position. So we would pass in array example, and I want to remove 200. It is at the second index. So we would just put 2, and then it would magically remove it from the table here. If you want to remove a value from a dictionary, you just have to take its index and assign it to nil. So key value example, we could take that and remove 200 by setting it to nil. Then it'll just be magically gone. The last thing I want to show is called table.find. You can use table.find by giving it a haystack, which is just the table we want to search through. I'll use array example, as this only works on array tables, not dictionaries. And then we want to find the needle, which is the value we're searching for. So if I want to find where 300 is at in this array, I put in 300. So this will return the index for what we're searching for, which in this case is 300. So if we want to assign this to be a variable called index, index would equal 3, as we're looking for 300, and that's where 300 is at. There's also a property for tables. It allows us to get the length of the table. In order to do so, I'm going to create a variable here. I'm going to call it the length. I'm going to set it to the pound symbol or hashtag symbol, and then I'm going to put the name of the variable for the array. So this will show you the length of the array, which is 3, as there's 3 elements within the table here. So this length variable is going to be set to 3 because this is 3. This does not work with dictionary tables. If you try to do this with my dictionary table here, it'll actually give you a warning here now. This is new. It says using hashtag on a table without an array part is likely a bug. It'll return 0 instead of the length. Okay, so we have all these tables, but what if we wanted to, say, go through each element and run an action for each element? Well, Luau actually has a way to do that. They're called for loops. There's 2 ways that we can iterate through a table. One method works for both types of tables. The other only works for array tables. So I'm going to go ahead and create a new table here real quick. And I'm going to add some values that we're going to run some multiplication on. Around 10, 20, 30. I want to go through each element here and run a specific action. So in order to loop through everything, we can use the for label here. Now after for, we're going to define 2 variables. These 2 variables are the key or the index and the value. Remember that this table here has these imaginary indexes, 1, 2, and 3. So I'm going to write I for my index variable, and then V for my value. And then we have to write in to specify what we're going to iterate inside of. I'm going to iterate inside of table here, so I'll write table, and then I'll write do. And then to end off the for loop, you add end to the end of it. Now in here, this code will run for every element inside of the table. I and V will be different for each element in here. So the first time it runs, I'm going to say I equals 1 for the first index, and V equals 10 for the first. Same would apply for 20. I would be 2, V would be 20, I would be 3, V would be 30. So let's say we want to print something for each value. I'm going to write the multiplied value of ... V ... is ... V times 10. So for every element inside a table, it would print the multiplied value of that value is that value times 10. If we wanted to make this easier to read, we could make this say number instead. And since we never use the index for this, we could just make an underscore to hide it. Now we'd have to go and update our variables right here. So now it says the multiplied value of number is number times 10. We could also flip the roll around here. Maybe we want to print the index for every single value within our table. So we could say the multiplied index of index is index times 10. So now it would print 1 is 10, 2 is 20, 3 is 30, because we're multiplying by 10. This would also apply to key value tables, which are dictionaries. So if we have key 1 here, and we set it to test, key 2, test 2. If we were to iterate through this for index, comma, value in table 2, do, the index for each one would be key 1, and then it would say the value is test, key 2 is the new index, and then test 2 is the new value. But another type of loop with the for loop is this one. So for index equals 1, aka the starting range of the loop, and then we put the end of the loop. So this will iterate through 1 to 10. Do, I'll just print index here. So this will print 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because we're starting at 1, we're going to 10. You could also do 10 to 1. This wouldn't work quite yet because there's a third comma we can do to say what we want to iterate by. So we start at 10, we go to 1, go down by 1. So we start at 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, like such. And you can make this any value you want. So you could do 1, 10, 5. So this would just go from 1 to 6 and then stop because it can't step to 10. It will go over the range. We could use this to iterate through this table. Instead of indexing at a predefined number here, we could change it to the length of the table here. So we could do hashtag TBL. This would give us our index. In order to get our value, we would assign a variable. We would get the table and then provide the index, which is this. So value would be the indexed index of this loop. So now value would be 10, then it would go to the next number, which is 2, get the value, which is the second index, 20, would go and print that. Then we'd loop again, go to 3, get the value by indexing the table, 30, prints that, prints 30. Well, then we hit the end of the loop. We're done. The loop's over. All right. So we've learned what tables are, how they work, how we can iterate through them, access them, modify them, all that. Why? I want to go over the Roblox data model. The data model is basically everything you see in this Explorer here. Its root is called game. and all of its children are these instances right here. Children can have children, which can have children. They all are like a tree going down. It is basically a table. It is a table. It's a bunch of nested tables within each other. So for example here, if I create a little label called game, this is the root, this is the data model. It branches off into separate things like workspace. It could also go to different properties like lighting. Workspace could have, I don't know, a part in it. It could also have the camera. So you can see it's almost like a tree that just goes off into different properties. Branches and branches and branches, going everywhere, like a tree. So we can follow this similar syntax to access all these values. So we begin with game, then we use the dot, go to workspace, and then we go to the camera, for example, if we wanted to go to the camera. The camera also has different properties, like its C-frame. C-frame is a way of storing position and rotation in one spot. So this would be like the camera's position in the world. We could do camera dot C-frame. We could get the parts color. Part has a property called color. So instead of doing camera, we could do part and then index its color. We could even assign the color to be a different color. Think back to color3.fromRGB. We could use that to assign the color. So there's all these different properties here, all like a tree for their children and their properties, like a giant tree. So let's say we're making a game and we want to change the game to be nighttime suddenly. Well, we could do that. Let's figure out what property we would need to edit in order to make it nighttime. So if we go to our Explorer here, we use context clues to think that the time of day would probably be in lighting. We click lighting and then go to our properties panel. Here we have all these different properties, including clock time. So we want to figure out how to edit lighting's clock time to be probably around 3 or 4. So let's go ahead and open up one of our scripts. Remember in my little example, we start by writing game in order to access the data model. And then we want to access lighting. So we would type lighting. And now we want to edit that clock time property. We can see that it takes in a number, numerical representation in hours of the current time of day used by lighting. Good to know. We take that and we set it to 3. So now it'll be 3 a.m. within the game when the script runs. We can go ahead and test it out by going to the test tab, clicking down and clicking run. And you can see instantly it turns to nighttime, just like that, because the script runs. Now it's nighttime within our game. So that's how we edit properties within the world. That's how we edit existing things in the world. What if I want to create something new within the world? Well, the main way to do that is with a function called Instance.new. Instance.new takes in a string, which is the name of the instance we want to create. So there's many different instances like parts, seats, mesh parts, sounds, spotlights, point lights, etc. Many, many, many instances. So many options. I'm going to start with a basic part, just to show off. You can see it autofills all these different options. I'm just going to create a part. Well, we created this part, but we haven't really done anything with it. In order to do anything with it, we need to assign it to a variable so we can edit it. So I will name this variable new part. So now new part creates a new instance part. We could edit different properties like its color. We could change its color to be a from RGB and change it to green color. Maybe I want to move the part up in the air a little bit. I could change its position to be a vector 3. A vector 3 is 3 axes, X, Y, and Z, which represents its position within the world. We could do vector3.new. I'll keep it in the center of the world on the x-axis. Maybe I'll move it up by 10 so it's in the air. And I'll keep it zeroed on the z-axis as well. Alright, I edited some properties. I'm really happy with it. how do we make it appear in the world? Because right now, if we ran this, nothing would happen. That's because new part isn't parented anywhere. Remember the tree. Right now, this part is not even attached to the tree. It's in the void. So we can take new part, edit the parent property, and in order to see this within the world, everything you see in the world is parented to workspace. So we can write game.workspace to parent it to workspace. So now if we went and ran our game again, you can see that a part suddenly creates and falls down because the part isn't anchored. All parts have an anchored property. That's what makes them stay floating. It did everything we wanted to it. Created a part, set its color. It went in the sky a little bit because I changed the position to be up a little higher, and it parented to workspace. It's pretty much everything for creating instances. There's also a property called clone. Clone is a way to create a direct copy of the instance. The only thing that's stripped from the instance is its parent. So when you clone something, it's no longer attached to the tree. So if I wanted to create a duplicate of this part, calling it part 1, we can just say new part, and then call the clone function for the part. You have to use a colon here to call this function. There's a reason for it. It's because it invokes a thing called self onto the function. I'll get into that in a later episode when we get into classes, but that's just a basic reason for why you have to do that. So we created this clone of the part. Maybe I want to move its position. I could take part 1's position and add another vector to it. Maybe I'll move it to the right by like 25 studs. Like that, 25 studs to the right on the x-axis. Now that we've done everything we wanted to, we can just parent it back into workspace. So I'll just take part 1 and I'll parent it to game.workspace. So now if we go ahead and test again, you can see one part appears there, one part's over there because we moved it to the right 25 studs. Alright, I have a little homework challenge for everyone here now. So the challenge is to create a table containing a list of color3.from RGB values. Now, for every color within the table of colors, I want you to create a new part instance. I want you to make the part instance have its color property assigned to the color that you are going through. After you assign the color, I want you to parent the part to workspace. So I'm going to go ahead and give you time to do that now. Go ahead and give it a shot. I recommend that you do it, as it'll help you learn. If you can't do it, that's fine. So go ahead and pause the video now, and I'll go ahead and show how to do it in a moment here. Alright, I got a few different solutions I'm going to show off. All of these are correct. You may have done it another way, and that's completely alright. It's okay to do it different ways. So to begin, I'm going to create a variable for my color table. I'm going to add some colors within it. Now that we've created our color table, that marks off the first step. Next, it wants us to go through every color within the table of colors. Remember, we have a for loop that we can do to do that. We can do for I color in colors do. Now that we've created the for loop, we need to create a part instance for every color. To do that, we could define a new part by using Instance.new. Then it wants to set the color property for the part to be the current color we're iterating through. So to do that, we can do part.color and assign it to the color value for what we're indexing. After that, it says to parent the part to workspace. So now we can do part.parent equals game.workspace. This is one way to solve it. And if we go ahead and test out the game here, you can see that only one part appears, which is very strange. But if you actually look into this a little bit more, you can see that the two other parts are hidden in the spawn plate. This is because when we create the parts, position 000 is right here in the middle, which creates two parts that get stuck right here and then one goes on top. So the second solution we could do to fix this is modify parts position. We could make the position be 5 studs in the air. Now if we went back to test again, you can see that the parts all spawn on top and land down below. There's one other possible way you could have done this. Instead of constantly creating these parts for every loop, we could create one base part outside of the loop, set its position right here, create a cloned part of the base parts. And then we can assign the cloned part's color to be the color, and parent the cloned part to workspace. So this would take our base part, put it the position up here, then we could clone it, color it, parent it. If we go and test again, you can see it does the same exact thing, just like the other solutions. So there's many different ways you can create solutions for your problems, and they don't all have to be the right way. There is no right way. There's different methods. Some might be more optimized than others. Some might be worse. It all just depends, and it's completely okay. So that sums up this episode of my Roblox Luau learning course. I hope you learned something new today. There's much more that we're going to be able to go over in the future, and I'm really excited to get into that. But I hope that you use this newfound knowledge to create something epic. Now we can actually create things within the world and modify them and make fun things happen. So go and have some fun with that. Thank you for watching.